In the Naming Simple Alkanes podcast, we are going to take some of the prefixes and the suffix that we learned from our last podcast, and we're going to talk about how to name simple alkanes that don't have branches. All right, let's go through our steps for naming alkanes. So the first step, and you will find this is the first step when you're naming any organic molecule, is to find and name the longest continuous carbon chain. So you really want to make sure that you utilize a highlighter or a pencil and you draw a line through the longest continuous chain so that you are recognizing how many carbons long it is and whether or not you have branches. You'll number the chain so the branches have the lowest possible numbers. So for example, if we had a carbon chain, and this is a basic example, let's make it 4 carbons long. I'm going to have to figure out what my longest chain is. Right here, 4 carbons long, it's continuous. Now I then have to figure out, how do I number this carbon chain to give that bromine the lowest possible number? I'm going to count from both directions to do this. I can count left to right, 1, 2, 3, 4, and that puts bromine in the 3rd position. Or I can count going the opposite direction, because remember, these are in space. There is no left to right, up and down. They move all around. I can count right to left, 1, 2, 3, 4. If I count right to left, that gives me a lower position for that branch. That is the correct direction to count in. And that's what it means by numbering the chain, so the branches have the lowest possible numbers. Then I name the branch. This branch is a bromine, so I would call it bromo. If you have 2 or more of the same branches, say I have 2 bromines coming off, like this. Instead of saying bromo, because that's redundant, we're chemists, we're not going to write that twice. We're going to use the prefix di for 2, tri for 3, or tetra for 4. So in this case, if I have 2 bromos, we would call it dibromo. And if you have 2 more branches that exist, say they're different branches this time, when you're naming that organic molecule, you're going to make sure when you name it that you put the branch that is first alphabetically first in the name as well. So for example, bromo would come before chloro, and both of those would come before methyl. If I have 2 of them, say it's dibromo, I don't include the di or the tri or the tetra when I'm alphabetizing those. The best thing you can do is to practice this over and over and over until those rules start to become more natural. All right, so now it's time to practice what we've just learned. So the first thing we're going to do is we're going to count in every single direction possible, and you'll see why that's important in a minute, the longest continuous chain of carbons, because that's going to be our parent chain. I personally like to draw a red line or use my highlighter to draw a line through that so that I know not to count those carbons as a branch or as anything else. It's going to get a little confusing later. So I have 1, 2, 3, 4 carbons. I have no other direction carbons would be in. If I counted the opposite direction, because you always want to be in the habit of counting each direction, we'll find out more why we're starting to create the habits that are going to make you more successful once these get more complicated. So 4 carbons long, I'm going to go ahead and put a line through my longest parent chain. I know I can't count those again as a branch. The prefix for 4 is bute. And looking at this, I have carbons that all have single bonds to other carbons. There's no double bonds, and it's only carbons and hydrogens. So this is an alkane, so I end the name with ane. So the name of this compound is butane. All right, here's another structure. So again, we're going to count in every single direction. You should be able to take your pen from 1 carbon to the end of your parent chain without lifting up. If you can do that, that is your longest chain. If there is something coming off of that chain that you would have to pick up your pen for, it is not considered part of the longest chain. So looking at this next structure, I'm going to draw an arrow just so you know that is butane. We are going to count in every direction. I have 1, 2, 3, and guess what? My pen would not pick up off the paper to make that the longest chain. So what's tricky is the thought that these compounds are actually in space. They're 3D. I can twist them, I can turn them, I can move them. We just happen to represent them on a 2D plane. So this is bent, but it's still 4 carbons long in its longest parent chain. So therefore, and I'm going to try counting the other direction just to be sure, and again, this won't matter until later, but we're creating habits for later. It is, once again, the longest chain is 4 carbons long. Prefix for 4 is bute, and we have all single bonds between carbons. We don't have anything other than carbon and hydrogen, so this is an alkane. We end this with ane, so this is also butane. In our next example, we're again going to start by finding the longest continuous chain of carbon. So, moving my pen through, that's as far as I can go. 1, 2, 3 carbons. The prefix for 3 is prop. And I'm going to look again to make sure what family this belongs to. It's all carbons and hydrogens. So it's either alkane, alkene, or alkyne, but they're all single bonds between the carbons. So therefore, this is an alkane, and we end the word with ane. So notice that the prefix tells us how many carbons, and the suffix, or the end of that, my pinky's making worse. The suffix is going to tell us what family it belongs to. So this is propane.